I'm happy to introduce today to you a framework called Drift. What is Drift? Drift is direct rendering. Yeah, and now I've managed to get my screen out. Rendering infrastructure. What this will allow you to do in future is, well, first of all, it's a research project for multiple companies with Best Solution leading it. It allows you to directly embed OpenGL content in your JavaFX application. Don't fuss around with the scene graph anymore if you have really big, complex rendering infrastructures. This is something that we implemented together with 3 partner companies. Netherlight, a company in the automotive space and aviation industry. Eclipse, a consulting company located in Munich. And Best Solution leading the complete effort. What can you do with that? Just the background. This is a JavaFX application. It doesn't look that nice, but the cool thing is we are now loading a 3D model, which is around 1.5 gigabyte in memory. We can navigate in this model. You see, this is the JavaFX front side. This is our 3D model. We can zoom in, we can zoom out, we can rotate. This is a native rendering technology that was developed for 10 years. But we can now embed it into JavaFX to create a business UI on top of that. Right? So we can manipulate the complete scene graph. You see, it's in the background. JavaFX is overlaying it. It's just a node in the scene graph that we're seeing here. It's just coming from an external system. Let's see what he's now adding stuff to the scene graph dynamically. Well, when he zooms out, you will see how big the model really is. It's amazing. This is a fab with every robot in this factory. That's an automotive factory that we are seeing here. This is an application built by Netherlight. So you now see, well, we added the whole fab, and now we zoom out and see how big this fab is, right? But there's every single robot in this factory is in this model. Drift. Drift works like this. We have the GVM, we have JavaFX. We have the Drift API. We have the Drift native API. And we have our existing rendering OpenGL code base. What we do at runtime, or technically, don't ask me about the details. I'm not that deep. I'm the manager of this project. I'm not the programmer or the guy who implements that. So we have JFX and we have our native renderer. And what we do, we create a texture in JavaFX and expose that to our JFX APIs or framework. And then we present another OpenGL texture to the outside world. And when you draw on this texture, we split it through to JavaFX. And it's part of the scene graph. We support in-process support. We have on Windows, we support 3D as external rendering technology. OpenGL, we cannot support Metal there. We probably could support Vulkan. We haven't looked at that. On OS X, support OpenGL. We know that we could support Metal. That's what we know. We didn't implement it. And on Linux, we just support OpenGL, but we are fairly certain we could support Vulkan there as well. This is a demo running. This is OpenGL demos running on NEC, then on Windows. And yeah, come over. That's how long we will know that this is Windows. And here we are running on Linux. The same OpenGL code in JavaFX. Completely integrated into the scene graph. What do I mean with that? Fully integrated into the scene graph. Let me just bring up my demo. I'm running out of time, but give me a second to show you that this is real. Our desk code. So I can run that guy, hopefully. So we start the external rendering process. This is our triangle. Then we animate that. These are JavaFX animations. Fading in, fading out, resizing. We can overlay it with JavaFX content. We can even apply effects on it. Cool, right? So this is fully integrated in the JavaFX scene graph. It's just a node for JavaFX, and we can apply transformations, effects on this guy. And it works on Windows, Linux, and OS X. Isn't it cool? We also support multi-process support. We can support external process rendering. So the renderer can run in its own process on the operating system. The demo I showed you with the factory. This was running in an external process and going cross-process. So when the rendering dies, your application is not dying, for example. This is very important to some applications. We only support that on OpenGL on Windows, and on Windows we have OpenGL and 3DD. On OS X we have OpenGL. On Linux we cannot do cross-process. We probably could with Vulkan APIs, but we've not explored that yet. And I have a big announcement to make today. We are, and have an hour ago, open sourced the Drift API inside the FX Clipse project. The pull request is there. What's missing yet? We need to go to the contribution process at Eclipse. Caveat, we only support Java 8 at the moment, but we could do that in Java 11 without a problem. But by reaching to internals and by adding, really, we cannot, there's no public API for that. But generally speaking, the code is easily ported to Java 11 as well in future, and that's the future plan, for sure. But currently, we are targeting JavaFX 8. Oh, and the final thing, if you want to work on not just boring business UIs together with me, we are hiring in Innsbruck. Innsbruck is a nice location to live. So if you need a job, apply for it, and we can do such amazing projects together. Thank you.